Geometry 5.1 Day 1 Notes over polygon sum conjecture and interior angles of a regular polygon. So first off, I just want you to refresh what are the names of the polygons with this amount of sides. So for example, 3-sided is a triangle. 4-sided, the generic term would be a quadrilateral. There we go. Go ahead and pause the video and see if you can answer some of the other ones. Earlier in the year, we gave you these, but you didn't have to have them memorized yet. Now we're going to have them memorized this chapter. All right, so go ahead and pause the video and unpause it when you're ready. All right, so go ahead and look at the examples. Quadrilateral 5-sided is pentagon. 6-sided would be hexagon. 7-sided is heptagon. 8, octagon, nonagon, decagon, undecagon, dodecagon. All right, so make sure you have those down accurately, and then we'll jump down to the warm-ups below. All right, so the first thing, we're just kind of reviewing the angles in a triangle. We're going to need to know the angles of different shapes today. So let's look at these first ones. So remember that the 2 interior angles in a triangle equal that 1 exterior angle. So we can add 40 plus 50 to equal that outside angle. So x would be 90 degrees. For the next one is asking you to find angle, the measure of angle ABD. So if we go from A to B to D, I want to know what this angle is. And remember, since those lines are parallel, it's the same as this angle over here by alternate interior angles. So the measure of angle ABD would be 60 degrees. And then we actually need to use that measure to find the next angle. So 60 degrees. The next angle is angle ADB. Well, now you have a triangle. So this is the angle I want. I know the other 2 angles in a triangle, so I can subtract to get that third angle. So we can go 60 plus 70 plus x. Remember that degrees in a triangle is 180. So we can subtract 130 from 180 to get the angle to be 50 degrees. All right, and the last one kind of can start with that same idea about the degrees in a triangle. We have 30 and 50 and z to equal 180. So we can add those up and subtract from 180. So that'll be your z, 100 degrees. Now that kind of helps us figure out y as well, because if these lines are parallel, cut by transversal, if that z is 100, well then by corresponding angles, this angle is also 100. So then 100 plus y, those make a straight line right there. So together those 2 angles equal 180 degrees. So we can subtract 100. So y is 180 minus 100, or just 80 degrees. Okay, and then x, we can use that same idea. Parallel lines cut by transversal. Corresponding angles are equal. So x would be 30 degrees. All right, another little thing to refresh, convex versus concave. Concave, I think, is the easy one. That's where it goes in. Your shape caves in. Convex is where your shape stays out. Okay? My stylus isn't working great, so sorry about the jagged lines, but it should be straight lines there. All right, let's go to the next page, page 3. So there's a correlation between the number of sides of a polygon and how much degree is in the polygon. So if it has 3 sides, that means it only is making 1 triangle, and there is 180 degrees in that triangle. Okay, if it has 4 sides, now what I can do is I can cut this down the middle. So the angles over here on the left add up to be 180, and the angles on kind of the right side add up to 180. So since there's two triangles formed, we can take 2 times that 180 to get 360 degrees. Okay, if it's a pentagon, we're just going to start at one vertex there. And if we connect that to see how many triangles, there's 1, 2, 3 triangles there. So if we have 3 triangles, and in each of those triangles there's 180 degrees, that would be 540 degrees. Okay, in 6-sided, again, just pick one vertex to start at to figure out the amount of triangles. 1, 2, 3, 4. Then we can take those 4 triangles times 180 degrees, and we get 720 degrees. All right, so what's happening each time? So notice the difference between the top number and the second number there. The number of sides to the number of triangles. It's always 2 less. So like this one, 7, that we don't have the shape for, we can just subtract 2 to get 5. And then we just take that 5 times 180 degrees to see how much degrees is in the triangle. So that one would be 900 degrees. Okay, so 8 minus 2 is 6. 6 times 180, 1080 degrees. Then if we add insides, we can take n minus 2. This will be how we figure out the formula. Number of sides minus 2. And then if we multiply that times our 180, 180 times number of sides minus 2. And that's how we'll find the degree of any number of sides. So that'll be the formula. So the polygon sum conjecture says the sum of the measures of the interior angles of an n-gon is sum equals 180 times n minus 2. All right, so the first example, find the sum of the measures of the angles of a decagon. Now you don't need to draw this out, but I'm just going to draw it out so you guys can visualize what shape we have here. A decagon. So that is 10 sides. So we say n equals 10. So if we plug that into that sum equation, we're going S equals 180 times 10 minus 2. So think 10 sides minus 2 gives us the number of triangles. So then we go 180 times 8. And then we can calculate what 180 times 8 is. And that's 1,440 degrees. Okay. So now if we refresh that this is a regular polygon, which means all sides and all angles are congruent, are equal. And for this next question, we want to know what is each angle of a regular dodecagon. So since it has 10 sides, it's going to have 10 angles in here. So what we just figured out in that first example was that all 10 of these angles together equal 1,440 degrees. But now I want to know what each angle is. So what I'm going to do is take that 1,440 degrees and divide it by the number of angles, which is the same as the number of sides. So we're going to say what each angle is, 1,440 divided by 10. So that's going to get us the interior angle. So then that's going to be 144 degrees. So if all 10 of these angles were exactly the same, they're going to be 144 degrees. 144 degrees, and so on. They'll all be the same degrees. Okay, so we can rewrite that with a formula. Interior angle of a regular polygon. So the interior angle is going to equal, you can do the sum of the degrees divided by the number of sides, Or what was that sum equation? That was 180 times n minus 2 all divided by n. So that's how we can get one angle if the polygon is regular. All right, so let's go down to this example 1. So first thing we need to do on an example like this is figure out how many sides does our shape have. So if you look at kind of the inside shape here, it's got 1 side, 2, 3, 4, 5. So on this one, we're going to let n be 5. So if I want to know how much degree is in this polygon, I can say the sum of the angles should equal 180 times n minus 2. Well, in our case, n is 5, so I can take 180 times 5 minus 2. And then if I do that, 180 times 3, then my sum is 540 degrees. Okay, so I need to find all of these missing angles on the picture. All right, so right now you can see this angle's a 90. We've got 110, so we already know those two. Over here, we've got this 80 degrees is the exterior angle, but we're missing the interior angle. Remember that when they make a straight line like that, we can subtract from 180. So to find A, we can take 80 plus A equals 180, or just 180 minus 80. So A is 100. So now I got that angle. We're going to need that later. So I'm just going to jot it in the picture. Okay, next angle. Notice B down here is straight line with 60. So we can subtract from 180 to get what B is. So we can go B plus 60 equals 180. Subtract 60 to get B to be 120 degrees. So B is 120. Okay, now C, this is the one that has no link. But remember earlier, we said that the degree in a pentagon, 5 sides, is 540. So what we can do here to find what C is, we can just subtract all the angles that we already know from 540. So look at the angles that we know. We know 90 degrees. We know 110 degrees. We know 100 degrees. And 120. The only one we did not know was C. So now we're going to set that equal to the total degree in the shape, which is 540. So add up the ones you already know. 200, 300, 420 degrees plus C should equal 540 degrees. So now I can subtract the 420 and get 120. So this shows that C is 120. B was 120 and A was 100 degrees. Okay? All right, for example 2, we can start that one out because it said that these two angles are the same. So if that angle is 120, well then so is this angle. Also, we know that B and 72 make a straight line, so we can subtract from 180 to figure out angle B. So all we have left is that angle A. Now this one happens to again be a pentagon. So it has 1 side, 2 side, 3, 4, and 5 sides, which is just going to be the same number we got in example 1. So the sum of the degrees again is 540. So what I need to do is add up all the angles I know. So I'm going to start with 108 plus 90 plus 120 plus 120 plus A and set that equal to 540. Okay, so add all those up and try to figure out what A is. If you already have this done, the assignment is a Canvas quiz. Make sure you're using your computer to access the quiz and not your phone. If you do not have your computer charged today, you could work on your Chapter 4 packet. All right, if we figured out what this last angle is, we could add all these up. 120 plus 120, there's 240. Plus 90, there's 330. Plus 108, there's 438. So I've used 438 degrees. How much is left for angle A if all the angles together equal 540 degrees? So then we can subtract that angle A, 540 minus 438, to get angle A to be 102 degrees. Okay, again, just go ahead and hop on Canvas, and you can do the 5.1 day 1 assignment. Do it as many times as you need to. All right, have a great day.